It is my incredible pleasure to introduce Lenny Giuliano. Lenny is one of the smartest guys in networking I know. Yep, he's going to be embarrassed, and I don't really care. I had the pleasure of working with Lenny on and off for a very long time. And better than that, he's a really good friend. Lenny, it is all yours.
Thank you. So tonight I'm going to talk about how a network technology can bring Steph Curry, Mark Andreessen, and Taylor Swift into your living room, all while solving what I would argue is the most challenging scaling problem on the internet today. So let's start with the problem statement before we jump into the technology. And the question is, can brute force unicast keep up forever when it comes to live streaming? So as live audiences are kind of exploding, combine that with increasing bit rates for things like 4K and 8K and AR, are we hitting an inflection point for the resources, for stressing the resources of a network when it comes to live streaming? This is a problem that has really manifested itself in the last, I would say, 2.5 years. It was really 2.5 years ago that Thursday Night Football, for the first time ever, was streamed exclusively online. And that was, and ever since then, every Thursday night, for 3 hours a night, 17 nights a year, you see 10 to 15 million streaming viewers. Comcast came out and announced that 25% of all internet traffic on a Thursday night is one football game, which is kind of mind-blowing. It continued on with the next year. NFL Sunday Ticket is streamed live exclusively on YouTube. And the next year, Peacock streamed exclusively one football game. And that had a viewership of 23 million viewers. That was a US record at the time. And then in 2023, we saw a series of records just being shattered, on a almost weekly basis, with cricket between the India Premier League and the India World Cup. In the summer, the IPL Championship had 32 million concurrent viewers streaming. And then in the World Cup, the quarterfinals had 43 million, 34 million, the semis had 43 million, and the finals had like 59 million. These are kind of mind-blowing numbers, right? And then late last year, you may remember the Tyson-Paul fight, right? I guess you do remember. And that was a record, that still stands as the record. 65 million concurrent streams. That set the record. It also set a record with 85,000 reported complaints and 2 class action lawsuits. Today, live streaming is responsible for 17% of all internet traffic. It was less than 1% 10 years ago. Now, some people say, look, video's video. What does it matter if it's live or if it's a Netflix movie? Shouldn't matter. Video's video, right? If everybody's watching Netflix movies and now they're watching live streaming, what's the difference? The key thing to keep in mind is live streaming is fundamentally different than on-demand streaming. And the reason is, first of all, latency. Low latency is the expectation. To match broadcast television, it's got to be less than 10 seconds. 5 to 10 seconds matches broadcast television. If it's longer than that, you run the risk of getting a text message from your friend about the game-winning score a minute before it happens, right? Before you see it. Or you hear people in the bar next door cheering and, a minute before you see it. When it comes to on-demand, if it's a movie, you can have a 2-minute play-out buffer. You can't do that with live streaming. The second thing is join rates are vastly different. If you look at the typical internet traffic graph of pretty much any network, did anybody here work for service providers? Okay. Or have worked for service providers at some point in their career? If you look at the typical traffic pattern on a daily basis, it's this diurnal pattern where it goes up from like 9 to 5 and then drops and then spikes up from about 8 p.m. to midnight as people go home and watch Netflix and Hulu. It is vastly, it is a big difference from peak to trough, but it is predictable and smooth. When it comes to a game, you have everybody tuning in, just as the game is starting, and they're tuning out just as the game is ending. So it's more like a step function than a smooth, predictable graph. One other thing to keep in mind. I mentioned that Thursday Night Football is 25% of all internet traffic. I should also mention that Amazon, with all their resources, still is not showing these games in 4K. Ask yourself why. Is it because people don't care about 4K? Keep in mind, if those games were in 4K, would be about triple the bit rate of what they use today. So just imagine that. If they were to match broadcast television, which is, or what you get over, on broadcast TV, which is typically, 4K, you could triple that number, and that number is already 25% of all internet traffic. So that gives you an idea of the challenge here. But the key thing to remember is the internet is not about just bringing a technology that's been around for 75 years just on a different screen and with the hope of being almost as good. The internet is about bringing new things, content that wasn't possible before, immersive content that you couldn't get before. So ask yourself, forget about just watching, a game on the screen like this. What if you could get that experience of what it's like to sit front row, center court at, let's say, a Golden State Warriors game, where you are sitting there, you're watching Steph and Draymond, and to the left of you is Mark Andreessen, and to the right of you is Adele, and you could listen to Mark and Adele talk to one another and watch Steph and watch an incredible experience. To get that experience, that front row center court experience in the real world, one, you'd have to go into San Francisco. Two, you'd have to pay. Those tickets are about $10,000 a piece. Parking is about $75, and each beer is $17. Right? That's what it costs. Now, what if you could get that same experience by slapping on some AR goggles, sitting at your couch, not having to pay $75 for parking? The beer would be a lot less expensive than $17 a glass. And instead of paying 10 grand for this experience, maybe you spend, maybe $200 for that experience, right? So the question is, if this was available, live streaming, mass audience for AR, is this possible with today's internet? Again, today's internet cannot handle 4K. How could it handle this kind of experience, right? With tens of thousands, maybe tens of millions of viewers simultaneously wanting to get that experience. Could that work today? Or what would it be like to be in the suite with Taylor Swift and her boyfriend's mom and her drunk brother shotgunning beers in the background? Just think how much people would be willing to pay, certain people would be willing to pay for the experience to sit and feel and hear what it's like to be in that box. And just imagine the people who might be interested in that, who perhaps never really cared much about football. And they show up for Tay-Tay, and they discover Pat Mahomes this is kind of fun to watch, and they become lifelong football fans. So you could imagine the opportunity, the business opportunity here. And again, is this possible on the internet today? Well, if you believe that it's not quite possible, this takes us to the question of network-based replication. How could it be possible? How could we do this? And the implication is that you can't get there with the current content delivery architectures that are commonly used today. And it kind of implies some type of network-based replication. Now, many of you have probably experienced, in some way, multicast, right? Raise your hand if you've ever worked with multicast at all. Okay. Raise your hand if you're not happy to have ever had to work with multicast in the past. All right. So the key thing to keep in mind is multicast has been fairly successful in some places. So things like financial networks, it is absolutely vital. Like, it is a requirement on financial networks. It's pretty commonly used in video distribution networks, as well as VPN, service provider VPNs, and some enterprises rely on multicast significantly. But internet multicast, over-the-top multicast, multicast over the free love internet, not so much, right? So the question is why? What went wrong? Why is there no multicast over the internet like everyone predicted it would be in the 90s? So, and I'm going to focus today on that multicast there because that's what's interesting, right? The other multicast, enterprise, walled garden multicast, meh. It's being done, it's easy, it's used. But internet multicast isn't. And so we're going to focus on that. So whatever happened? What went wrong? Well, there's really three big problems with internet multicast. First and foremost, there's the all or nothing problem. The all or nothing problem just says that for multicast to work, every single layer 3 hop from source to receiver must be running a multicast routing protocol. What that means effectively is every single interface on every single router and every single firewall on the internet must be running something like PIM, a protocol like PIM. And that's in order to get ubiquitous service. And that's a really, really high bar to meet. Just ask the V6 people, because they have the same exact problem. And they've been trying to solve this problem for just about as long. We're going on 3 decades now. And multicast is, I'd say they're kind of technological cousins, multicast and V6. They're related, they're kind of cousins. They were born around the same time in the 90s. They had lots of high hopes from their parents. But they're still, I would say, V6 is doing a little bit better than its cousin multicast, but they're still kind of underemployed, let's say, living at home with their nervous parents, and wondering if they're ever going to, launch. And the fundamental problem with both is this all or nothing problem. The second problem with multicast, and for all of those of you who raised your hands about, probably have cursed multicast in the past, it is because of this is too complex problem, right? Where the perceived benefit is not worth the effort of deployment and operating. And it goes both ways. So on places like financial networks and video distribution networks, the perceived benefit is seen as worth the cost. And that's why it is deployed pretty commonly and typically in those networks. The same is also true. The perceived benefit on the internet has not been seen high enough. The juice has not been seen as worth the squeeze for the internet in the way that it has on financial networks. And therefore, it has, that's why it hasn't been deployed. And then finally, there's the chicken and egg problem. And the chicken and egg problem says, there's no multicast content because there's no multicast audience. And there's no multicast audience because there's no multicast content. Here's some good news. And this is why I'm here today to talk about TreeDN. And that is, there are technologies and components that comprise TreeDN that solve these problems. That's what TreeDN is built. It rests upon a set of technologies that kind of are designed specifically to address all three of these big problems. So TreeDN these are tree-based CDNs. It's newly minted RFC 9706. And what it essentially does is it leverages native and overlay networking concepts to deliver services to end users, even if they're not on a multicast-enabled network, right? So there's these two components. There's the native part. We call that on-net. And then there's the overlay, and that is automatic multicast tunneling, AMT. And I'm going to kind of dive into each of these in a moment. The key thing is, one of the key benefits is incremental deployment. This was something that was never available previously. Again, with the all or nothing problem, it had to be everywhere or it was not useful at all. We can now, with TreeDN, get incremental deployment where the multicast-enabled parts of the network enjoy the benefits and the unicast-only parts of the network are tunneled over. Again, we call it we're not going to call it tunneling, we'll call it overlays. Because when I started in this business, tunneling was seen as a suboptimal hack to be to be avoided and circumvented. But if you just call it overlay networking, all the cool kids are doing it now, and it's very fashionable. So we call it overlays instead of tunnels. The key thing is end users, they don't care whether it's coming in via unicast, multicast, a tunnel, whatever. They get the content. They don't have to call up their service provider and say, do you support multicast, and have the person laugh at them on the other line. There's no dependencies on their last mile provider in order to get the service. It just works. All right, so let's dive into these components. So the first part, native on-net. So it turns out multicast isn't complex. Network-based source discovery is complex. And whenever people curse and complain about multicast, they usually has something to do with rendezvous points or PIM register messages or tree switchover or data-driven state creation or MSDP storms or some weird esoteric problem with PIM, all of which stems from the fact that in classical original multicast, the network was responsible for discovering all the sources. This would be roughly the equivalent of having OSPF and BGP discover every web page and know every web page on the internet. That's crazy. But yet, and we never would have done that. Doesn't scale. It's silly. And yet, we did that with multicast. And that's what the any source model was. Well, SSM came along and says, we're not doing source discovery in the network. We're going to let that be handled by the application layer. If the application layer is able to figure out the group address, it can figure out the source address as well. So we're just going to focus on SSM. And when you eliminate network-based source discovery, you eliminate 95% of the complexity of multicast. PIM SSM is a very, very small subset of the PIM sparse mode protocol, and it is vastly simpler. And then the second component is the overlays. So the native part gets you to the border of the multicast-enabled network, and then there's overlays that get you to the end user that is sitting on a unicast-only network. We're dynamically building, what AMT does is it dynamically builds tunnels that hops over those unicast-only parts of the network and delivers the content to the unicast, to those receivers on those unicast network. It not only solves the all or nothing problem, but it also solves the chicken and egg problem. So let's dive into AMT. What is it? First of all, has anybody ever heard of AMT? Okay, all right. My closest friends. Yeah, it's. I'm not referring to the horribly oppressive tax on the upper middle class. It is automatic multicast tunneling. So how does it work? So imagine you have a multicast-enabled service provider. There aren't many, but they do exist. And then imagine you have a multicast-enabled content owner. Again, there's not many, but they do exist. And then you have a multicast-enabled local service provider. Not a lot of them, but they do exist. So you have a bunch of interested receivers on the multicast-enabled local provider. They send joins. The traffic comes through in a way and is delivered from source to receivers such that no link carries more than a single copy of the data stream as God intended. This is how native multicast works, right? But the other 99% of the internet is unicast only. So how does it work there? Well, imagine you have an interested receiver who sends an IGMP report to their last hop router, and their last hop router isn't running multicast, so it just drops that message and doesn't know what to do with it. However, that last hop receiver has a thing called an AMT gateway client. We have amongst ourselves an actual AMT gateway client developer, Natalie here, who she actually developed a gateway client as an internship project and upstreamed it into VLC. So it's available today in VLC. Anyway, it is a thin client that runs on your laptop, a smartphone, an iPad, a smart TV, and it is able to discover magically an AMT relay that sits at a border of a multicast-enabled network. And a relay is kind of the tunnel server, the gateway is kind of the tunnel client. And the way AMT, the gateway and the client works is the gateway somehow magically discovers the relay, sets up a tunnel dynamically, a special UDP-enabled dynamic tunnel that gets built dynamically, and then it sends an IGMP report through that tunnel as if so that relay feels as if that gateway client is directly attached to it. The relay accepts that IGMP report as if it was a local receiver, turns it into a PIM join, joins the tree natively, receives the traffic natively, and then delivers it over the tunnel. As we have more interested receivers, they each get separate copies of the data stream. So the key thing here to note is the receivers receive the content regardless of what is going on. They have no dependencies on their local service provider. They just tunnel over that service provider. And oh, by the way, you can imagine a point where that local service provider discovers, gee, we have a bunch of duplicated unicast streams, tunnels, going through our network. Maybe we should turn on multicast natively so that we could more efficiently deliver this content instead of transporting lots and lots of duplicate streams. So you could think of AMT as kind of a stopover, not a destination, but it is that critical, necessary first step to get things working. All right, so what is TreeDN? TreeDN is simply SSM plus AMT. So you can see this is the big I internet, which is 99% multicast enabled, unicast only. And then imagine you have a TreeDN provider that is native multicast enabled. We'll call this the on-net part of the network. You have a content provider that connects to the TreeDN provider, and they have interested receivers that are directly connected to that network. And they receive the content natively, again, as God intended. Now imagine you have off-net receivers. These are receivers that are sitting on the unicast-only part of the network. For them, we have these AMT relays. We deliver the content natively to the relay, and then we tunnel it via AMT to those receivers. So the key thing is they get the content whether they're on the network or not. So you may say to yourself, gee, this sounds an awful lot like a CDN. Isn't this what CDNs do? And that is a very astute observation. So if you think about CDNs without multicast, what are CDNs actually doing? Right? They're essentially doing network-based replication. They're doing multicast without doing multicast. They're doing kind of unicast to unicast replication. So there's different CDN models, but a typical one is you have a network with a bunch of CDN boxes that are deployed throughout it, and the traffic goes from the content provider to those, it gets distributed to those CDN boxes, and those CDN boxes deliver the content to local receivers. The great part about it is you don't have to run a multicast routing protocol on every single interface on every single router and firewall on the internet. It just works, but at a cost. So this is what a CDN with multicast is, and we'll call this a TreeDN. Because it's a tree-based CDN. Notice first we move those CDN boxes. First we're going to rename them. We're going to call them AMT relays. We're going to move them further to the edge of the multicast-enabled network. We're going to send the content to them natively, only to receivers that have interested local receivers, and they handle local receivers. So it kind of looks pretty similar, right? Yeah. What's the difference? Well, there's some key differences. If you can deploy these on existing network infrastructure, so imagine these relays can be turned on and enabled in existing routers, that these aren't separate boxes, right? You can turn it on with a couple of knobs, software knobs, on existing routers. Then you can essentially offer this service at zero additional cost. You essentially have a CDN on a chip. And I would argue that even at zero OpEx as well, because you don't need to power a bunch of CDN boxes. The other nice thing is this is an open standards-based solution running mature protocols with minimal coordination with the content provider. So think about how CDNs work today. That CDN isn't just forwarding packets. It's doing stuff. You have to send that content to those servers. That servers have to store this data. They have to secure it. They have to participate in the transaction between the content provider and between the viewer and the content provider. They have to, do key exchange. So there's a lot of stuff going on. With TreeDN, there's no stuff. You're just forwarding packets. You're not storing it. You're not securing it, and you're not doing any kind of key exchange. So I want to kind of drill down a little deeper into this. So imagine, let's take one of those CDN boxes or these AMT relays and kind of blow it up and look at it, zoom in and see what this looks like. So imagine this is a traditional CDN, right? So you have content, and it needs to get to a bunch of eyeballs, right? So how does it get there? Well, first, you need a router, right? You need a bunch of servers also, right? Not enough servers. More servers. There we go. You have a bunch of servers. Of course, you need switches. And if you have a bunch of switches, you need switches to connect the switches, all to connect to the routers, right? And so the content comes in to the server farm, and the servers distribute the load and send it off to those interested eyeballs, right? So in one, out many, right? Just like multicast, except it's not multicast, it's unicast, but looks roughly similar, right? So how does it work? That's how a traditional CDN works. Well, how would it work with a TreeDN? Well, we got the same content and eyeballs. And of course, you need a router. But this router is a special router. It has AMT capable router. It's capable of being an AMT relay. And we send the content to that relay natively, and it builds a bunch of tunnels separately. So what's different here? We have avoided the massive costs of all those servers, all those switches, all plugging into expensive router ports. Those servers need to be racked, stacked, powered, cooled. So you could see this is a much, much, much more expensive solution. To give you an idea of the difference in cost, and I'll dive into this company a little bit later, but this is being used actively on the internet today, and one of these TreeDN customers was asked, why don't you just, instead of using multicast, why don't you just use unicast CDNs? And they said unicast CDNs are an order of magnitude more expensive than doing multicast. So there is significant cost here. So I have talked mostly about live streaming, video, cool, fun stuff, because that's the sexy use cases, right? But this works for any multi-destination content, right? It's typically going to be audio, video, think of something immersive, AR. But it could also be boring stuff that's really important, like telemetry data, right? Anything that's better live than on demand. So think sporting events. The top 3 use cases for live streaming is sports, sports, and sports, right? But after that, there's things like concerts. Think about Taylor Swift having simultaneous concerts in theaters so people can get that live experience. Think about e-learning, where you want to have an interactive experience. Worship services, conferences. I mean, the fact that I think 60 of you are all in here tonight, you could have just been watching this online on Zoom. And there's a reason you came, right? There's something special. Humans are designed to hang out and talk and be around one another, right? Anywhere where that live experience is different than on demand, this is where there's applicability. But the less sexy stuff, but probably more tactical and even more important, at this moment, is things like large file software uploads, right? How many of you have had to deal with, a giant multi-gig file that all of a sudden today everybody on their iPhone needs to download, or everybody, a bunch of gamers are downloading this giant file and it's wreaking havoc on your network today. Has anybody ever had to, deal with stuff like that, right? So these are the kinds of problems that TreeDN could solve. All right, so this stuff isn't just PowerPoint slides. Awesome PowerPoint slides. This stuff is real, and it's actually being deployed in production networks today. I'm going to talk about 2 of those. So there's 3 well-known deployments. I'm going to kind of dive into 2 of them. And the first one is UMetCast. So UMetSat is it's like we've all heard of NOAA, the National Oceanographic and Atmospheric Administration. UMetSat is the NOAA of Europe. And they operate a bunch of satellites that capture meteorological and atmospheric data. And they stream it out to research institutions, universities, the Weather Channel. This is real-time data that needs to be received within 60 seconds, otherwise it's useless data. And traditionally, they've used satellites, but that's really expensive. So they've tried to move the distribution of this traffic, of this telemetry data, from these satellites to many research institutions across the globe. They've tried to do this terrestrially. And again, these were the folks that said doing this via unicast is really expensive. So they've been doing this via multicast, and they connect to Géant. Anybody ever heard of Géant? Justin, it's Belgian, I think. Géant, you've all heard of Internet 2? Raise your hands, you've heard of Internet 2? Okay. Géant is like the Internet 2 of Europe. It is the NREN of Research Education Network of Europe, and different national and regional RENs within Europe connect to it. Anyway, Géant is a native multicast-enabled network, and UMetSat connects to them, and they deliver their content via native multicast over to their research institutions that connect to this network, or networks that connect to it. Now, the problem is a bunch of their clients, research institutions, universities, are not on multicast-enabled networks. So rather than doing GRE tunnels, which you have to manually configure on both sides, and these are tunnels that have to stay up, they're not ephemeral, they discovered AMT, and Géant deployed these AMT relays across their network, and basically tunnel out to UMetSat's customers who are on non-native multicast networks. They have reported that this isn't like, they love it. Both UMetSat loves it and Géant loves it. It's a huge success. They're going to be doing a talk about this at a conference next month about how successful it's been. But to give you an idea, like It's been so successful that UMetSat has upgraded their links from 10 gig to 100 gig, and their customers have been extremely happy with this. So that's UMetSat. That's probably the best known and most commercially viable deployment. There's also Internet 2. So TreeDN over Internet 2. And there are several institutions. The first one being Thomas Jefferson High School in Alexandria. So you guys probably all know about TJ. That place is amazing. And they were the first, they deployed the first AMT relay on the internet. Yeah, they're kind of like a small college. The cool thing is the kids basically run the network. They run all IT for the school. And they deployed, one of their students for his senior project deployed the world's first AMT relay on the internet. He operated, he ended up giving a talk at IETF about it. And subsequent to that, several other universities, University of Kansas, CanRen, George Washington University, CAREN, the Capital Area Research and Education Network, and Giont are all part of this network. There are 4 deployed relays. If anybody, by the way, is interested, you have a network that wants to connect to this network, come see me. We'd love to get more relays. You'll get a shirt out of it. See this awesome shirt? You put up a relay publicly, you get a shirt. And you can, to see this in action, another TJ student built the multicast menu. Go to menu.treedn.net. I would encourage you guys, check it out. Please do go home tonight and go to menu.treedn.net. And this was another student. She was a sophomore in high school at TJ. COVID hit and she was bored. She was stuck at home and she reached out and said, what can I work on? So I told her about this project and she built the multicast menu, which essentially finds all the multicast content on this network, captures the source, the group, the nearest relay, and you can click on it and it'll launch VLC, the VLC version that supports Natalie's AMT gateway client. And you can receive content. This is something you probably never thought was possible for those of you who've used multicast, but you can receive multicast in your house right now. So it's pretty cool. I would encourage everybody to check it out. Check out these links to learn more details about how it all works. You can see Lauren give her talks at IETF 115 and 116. Really fascinating stuff. So kind of summarize, what are the benefits of TreeDN? More efficient network utilization, right? You are delivering live content at an order of magnitude cheaper than traditional CDNs. Not only does it make things vastly less expensive, but it also makes content that previously wasn't possible now viable, right? Think AR live streaming. Think putting on those goggles and being able to get that experience, that front row center court experience for, let's say, $200. Or maybe you don't want to shell out $200 tonight. Maybe you just want to spend $50 for, second level first front row, right? And maybe it's $30 or something like that. But to get that experience that's more immersive than just watching it online. Obviously, you are. It also makes other perhaps less inspiring use cases like micro betting possible. So degenerate gamblers can bet on every single pitch to see if it'll be a strike or a ball. No judgment on them. If that's their thing, you do what you do. But that is a perfect use case for. It's pretty much identical to financial networks, right? They're kind of doing the same thing, and it's pretty much the same use case. It's just degenerate gamblers won't be bringing down our economy, in flash crashes. But never mind. So the cool thing about this is it's a much more sustainable and green technology. We saw all those racks and racks and racks of servers that are sucking up power and need to be cooled. It also, almost on a weekly basis, I hear from some telco exec who says, how can we deliver new networking services that will derive more revenue for us? And my answer usually is, well, nothing. People don't want new fancy services. They just want to get Netflix, and YouTube and Hulu, and they just want to watch streaming content at home cheaply and reliably. But the exception there is multicast, TreeDN. This is a way for large service providers to offer replication as a service. That's what TreeDN essentially is. That's what CDNs essentially are. And they can do so at a very, very low bar. Like, there are CDNs today. And if you look at those CDNs, they're not making a ton of money. And it's because it's really expensive to build that infrastructure. Well, this infrastructure, if you have the right routers deployed that support AMT relays out of the box, it's 5 lines of config. And you've just turned on your router, and it's an inline CDN on a chip. Far less coordination, far less complexity, and it's an open standards-based technology, as we talked about. And it addresses, the fundamental problems of network replication that we talked about. It gives you things like incremental deployment. It solves other problems like multicast over Wi-Fi, which we didn't talk about that today, but that's a little bit of a headache. So, kind of last slide is, in the past, the reason multicast never took off was because we didn't need it. Audience sizes weren't large enough for simultaneous content, and bit streams weren't large enough to matter. You could handle it with brute force unicast. Well, on both the supply and demand sides, things have changed. So everybody who's made a decision based on a lousy MSDP experience in 2006 and has tuned out and said, I'm never doing multicast again because multicast sucks, things are different now, okay? It's not 2006 anymore. On the demand side, there are exploding live stream audience sizes. It is now routinely happening on a weekly basis, tens of millions of people watching the same thing. And at increasing bit rates, 4K, 8K, think AR, right? So that's the demand side. And on the supply side, it's never been cheaper and easier to deploy a network-based replication mechanism. So that's what TreeDN is. It describes a model to address the increasing strain that comes from live streaming and enables this new content. So in the past, the reason people didn't deploy multicast on the internet was the juice just wasn't worth the squeeze. But now, it's never been easier to squeeze, and the juice has never been tastier. So with that, some references, and I think I'll conclude there and take as many questions as you have until Scott kicks me off. Questions? Fire at me. Scott hasn't given me the hook yet, so
let me prime the pump.
hit me.
Comment, then a question, and make sure you repeat.
Here.
It. No,
I'll repeat your question.
Nothing is ever a stopover technology. There's still Apple Talk turned on in networks. This makes so much sense. What took so long to come up with this tunnel hack, overlay, sophisticated solution?
All right, so to repeat Scott's question, first a comment that there's nothing more permanent than a temporary networking solution. And second, why aren't we there yet?
Yeah, well, it seems really simple and straightforward.
What took so long? Again, I would say the demand wasn't there up until recently. This has only been a problem in the last 2.5 years. And they've been doing it with brute force unicast the last 2 years to just make it work. Amazon Prime, Amazon can essentially print money. And so they have the resources to pay for this. Netflix sort of kind of thought they could too. And I think one of the biggest challenges, frankly, is multicast has a terrible brand. Like, raise your hand if you think multicast is fun and you want to operate a multicast network. right? Yeah, I mean, I'll raise my hand because I do. Like, that's my racket. But like, yes. Yeah, okay. A lot of people raise their hand for those of you not watching. No, nobody raised their hand. And the truth is, multicast has a terrible brand. People had, again, terrible experiences in 20 years ago that has colored their view of this technology, and they've said, I don't want to do it. And they haven't had to until now. And that's kind of the point. The juice up until now wasn't worth the squeeze. But now, I would argue that it is. We've hit the 65 million viewer problem. And that was just to watch an over-the-hill boxer get tuned up by, a meme guy who went easy on him. So, just imagine if it was a real fight that people really cared about. Yeah. And again, we're not there yet, sorta. But then look at a thing called Xstadium. I don't know if anybody's seen Xstadium, but essentially they do live streaming AR of events. They don't have audience sizes big enough, but at some point they will. And again, you can only go against the force of gravity for so long. Pigs can fly given sufficient thrust. But at some point, they can't go as far as you need them to go. So I guess that's why we're here, is to talk about cool new technologies to make people aware of them so that everybody can go off and start deploying TreeDN networks. Yeah.
TreeDN, who's got support for
So TreeDN is two components. There's the native component, and that is any routing vendor that supports native multicast. PIM sparse mode, MLDP, beer, whatever. PIM sparse mode is the main thing. So now, right. So the question was TreeDN, who supports it. So the native component is just a native multicast routing protocol. Everybody supports those. What about AMT? That's a good question. Remember, AMT is only needed at the relays, and there are two known commercial router vendors that support them. Juniper and Cisco. I'm told Cisco does have an implementation. Talk to your Cisco SE and ask them about it. I'm at Juniper, so I can't tell you much about their implementation. I can tell you a little bit about ours. I don't want to make this commercial, but I'll be happy to talk to answer any questions about Juniper's AMT implementation.
So on the client side, what's the look like? From it, any browser support this if possible?
All right, so the question is, what about on the client side? How does an AMT gateway client look? All right, so that's kind of a longer story. There's a longer story there. So first of all, you can build it into an app, which is exactly what Natalie did, right? And again, AMT is designed to be very developer friendly. So again, Natalie, as a college intern, was able to do this in 6 weeks, right? And you had what? 0 networking experience at the time. I think we went to lunch. I explained to you how the internet worked and routing and multicast, and she went off and went coding. And 6 weeks later, she had something to upstream. So while obviously Natalie is a rock star developer, she was a college intern at the time. I'm pretty sure that it shouldn't be that tough for the hyperscalers of the world to develop this into their apps and into their players. There's kind of a longer question there, right? So a lot of it is like TCP and QUIC. Obviously, TCP is not multicast friendly. QUIC can't do multicast yet, though there's a draft out there for multicast extensions to QUIC. QUIC is UDP-ish, right? So it is multicast friendly-ish once you get past the setup part. And also, if you look at Amazon Prime acquired a company called SYE, S-Y-E, a couple years ago, roughly right before they applied for the rights to Thursday Night Football. So they significantly used that SYE technology, which is a UDP-based delivery mechanism. So it is it could easily be done with multicast. So you have to build multicast capabilities into the client, sort of. Now, the browser. The browser's a challenge because the browsers are locked down. I've come to discover, for those of you who don't know this, there's like a browser mafia, and they do not let stuff in. Like Chrome controls it, and they only allow TCP and QUIC. They do not allow UDP into browsers. Did anybody know that? Like, you can't do UDP traffic into a browser. They literally just won't let you do it. So for browsers, the only way to get there is QUIC. That said, there are some hacks. So has anybody ever heard of DVB MABR? This isn't really a hack. So there's this thing called multicast adaptive bitrate. DVB is developed by a standards organization called DVB, Digital Video Broadcasters. I think that's what it stands for. And they've defined an architecture that describes a way to use existing players, unicast-only players like browsers, and they have, it's kind of like multicast has it's similar to AMT, where there's a multicast server to a multicast gateway, and then from the multicast gateway, it sends the traffic on through HTTP over whatever. Anyway, it goes multicast to a gateway, and the gateway sends it via TCP. HLS, sorry, HLS. So that could work, and that is a way that is being used currently in like Europe. I think TIM, Telecom Italia, they do multicast, and they use MABR, I believe, to deliver content to their end users, and then you don't have to mess with the clients. You just have to build a gateway in at the prem, which is, again, a pretty trivial thing. And we've been talking to the DVB people to say, hey, just make that gateway an AMT gateway as well, and then you can extend that to anywhere on the internet, where it could be a DVB MABR gateway as well as a TreeDN AMT gateway, and then it could be anywhere on the internet. There are other architectures. You may have heard of MAUD, Multicast Assisted Unicast Delivery. It's like a tweak on the MABR spec, came from British Telecom. It has some subtle differences, but roughly the same. From a multicast perspective, they have a multicast gateway. And then there's the SVTA is another standards body that is standardizing a technology called open caching. No, sorry, open casting. They also do open caching, but open casting, which also uses the similar. So this is the TLDR version of it is, yes, there are ways to get this to work with existing apps that are unicast only, but it would be better if they just added AMT gateway clients into their apps. Stefan.
Do you see any interest in web conferencing, webinar type applications like Zoom webinar using this?
The question was, what about conferencing, things like Zoom and WebEx Teams, those kinds of things? There is I've heard anecdotally that one of the big guys was looking into it and investigating it in the past, and in fact may have had an architecture that was well suited to it. They kind of abandoned it, in a organizational change. There's a company out there called Vivo that is working with Teams and Zoom to integrate into the Teams and Zoom ecosystem. But the short answer is, I don't know. I haven't spoken to anybody at Teams, Zoom, WebEx, or any of the others that you might be thinking of. I don't know that I could be wrong about this, but I don't know that they have situations where they have tens of millions of viewers simultaneously, where brute force unicast isn't good enough. But there's no reason it couldn't be. Why couldn't Zoom do, football games or basketball games, and presumably they might want to get that the rights to that, and then they would want to do that.
And we see on an enterprise network too, where tens of millions or hundreds of thousands of crushing enterprise networks.
Yeah, Stefan just said he could see this happening on enterprises where it may not be millions, but it may be thousands or tens of thousands, and that could crush an enterprise network. The thing is, a lot of those enterprises that have those issues, they actually do deploy multicast. Like multicast on walled garden enterprises is much easier, and it happens. Like multicast is probably, people beat up multicast and says nobody uses it, but the truth is, I would argue, I would throw this bet out there. I have no data behind it, but it is just a hunch after being in this field for a long time. There are more routers out there running multicast than running PIM sparse mode than there are running MPLS. And no one would suggest that MPLS has not been a success. But I would bet that there's more PIM sparse mode routers today than there are MPLS routers. I've thrown that out there, and no one has ever disagreed with me. Stefan, I can't tell if you're looking skeptically, but nobody else has. How could you ever prove it?
Gas stations are there in the United States?
Yeah. True. It's an assertion that I have zero data to support, but I'm sticking by it. So until somebody can disagree with me, I've never had anybody say, no, that doesn't sound right. Most people are like, yeah, that sounds about right. The issue is it's not interdomain, and that's the tough part. It's the interdomain multicast. It's the hard part. Enterprises, Verizon has actually talked about their IT network is completely native multicast enabled. They do multicast extensively for those kinds of things. The CEO giving a talk that everybody has to watch. That's, I think, fairly well deployed across a number of large enterprises. Last question. Okay. Happy to talk to anybody the rest of the night. Find me at the bar. Well done. Appreciate it.